Hey guys, this is Arsh. I'm back here, and today we're going to talk about NAT. So, the fact is, when we were talking about the IPv4 addresses, there was a big problem, a really big one. The fact is, IPv4 addresses are only limited to a number of 1 billion and something. So, with today's internet working and every, single family, they're going to have a tablet, a mobile phone, a PC, I don't know, a laptop, whatever it is, they tend to have more devices connected to the network. So it means that we need more IP addresses for those devices. But here's a problem. A public IPv4 address is actually allocated to ISP corporations. And if you want a public IPv4 address, you have to buy it from the ISP. So it doesn't really make sense for a home user to buy an IPv4 for every single device. For example, he got a tablet, he gotta go to buy an IPv4 for it. He got a mobile phone, he gotta go to buy a new IPv4, a public one. Doesn't really make sense, does it? So they created NAT. That there was a saying from the RFC 1918. First of all, you have to remember that any private IPv4 addresses is not routable through the internet. It's very important for you to know that. And with NAT, things are a bit changed. You see, the fact is IPv4s are not limited to 1 billion, and they're going to end soon. I mean, they're ended till now. I actually recording this video in 2023, and they've actually ended since I think 3 years ago. And I mean, ISP would still have IPv4 addresses. They still have some IPv4 addresses, but it's not too much. So we're using IPv6 these days. And with IPv4, there was NAT created, so let's see why NAT was there. So we said every single device of a home user have an IPv4, a private one. So these private IPv4 addresses, let's take a look at this uh, picture here. If I could get a pen, yes. Imagine this is host A, which is a laptop, get a private IPv4 of 192.168.1.102. And he tends to go to the internet. So the problem is that he got a private IPv4 address, and we know from the RFC 1918 that this private IPv4 address is not routable through the internet. So how we can actually make him to go to the internet? Well, there is a router that we have in our home, or could be a modem, whatever it is. This router does NAT. So what NAT does, it translates the private IPv4 address to public IP address. So how does it do that? So this laptop with the IP 192.168.1.102 tends to go to the internet. His packet goes through the router. It could be connected to the first port. Maybe it's wireless. It doesn't really matter, but let's think about that. This is a wired connection, and he's connected to the first port of this router, the port 1. So it's his private IPv4 address going to the router. The router does NAT using his NAT table. Could be configured from the ISP or ourselves. And the fact is, our router have at least one public IP address. So we still need the public IP address. But the fact is, how if we had two laptops and we have only one public IP address? Well, two laptops, for example, this one is connected to the second port. They have different private IP addresses. For example, this one got 192.168.1.103. So they both go through the router, and the router says, "Hold on, you are using private IP addresses, and I'm being told before using the NAT table that I have to translate your IP address to a public one. For example, 65.96.14.76, which is my public IP address. So I'm translating your IP to that IP, then I'm going to send that packet to the internet. So now it is routable through the internet. But hold on a second. We said we have two laptops. Are they using both the same IP address? Doesn't make sense, does it? Well, it does not. So that's why the NAT table would use something called port. So you see, for example, the first client, 192.168.1.101, would use a random port. For example, 57.847. So when the packet is going through the router and the router wants to do the NAT, what it basically going to tell himself is that I've got this IP address. If I clean this up, sorry. I got this IP address with these ports. I'm going to translate this one to this IP. But here's the fact. It goes through the internet. All right, that's fine. Using a port, could be a specific port. And when the answer is going to get back to the router, I mean the same IP address, okay, for both of the laptops, the router would know that the packet that went through the internet, which is now coming back to the router itself, which port did it use? So he's telling himself that the first client was using this port, which I sent the packet with a public IP. And when the answer is coming back using that port, I know which IP address it is because I have it in my NAT translation table. So this port was actually for this IP address. So I'm going to bind this packet to the laptop. And he is actually replying back to the laptop. That's how it knows which packet was from which client. Because, you know, if they're both using the same public IPv4, how the bloody hell are you gonna actually realize that which one of this laptop was using that IP? Because they're both using the same IP, but they're using different ports. So now he knows which laptop sent which packet. So that was a really brief talking about how NAT actually works. And you see, we got many clients, and they've got different IPv4 addresses, I mean private ones. So with that, the IPv4 addresses are not going to end soon anymore. See, we got 10 clients, we got 101, 103, 102, 104, for example. More and more on. So these are just private ones. We could have all these IP addresses, these private ones, in another house as well. In your neighbor's house, even in the corporation, we've got private IP addresses. Why the hell does those clients in the corporation would need public IP addresses? Doesn't make sense, does it? A corporation would likely to have 1,000 clients, and buying 1,000 public IP address for just a single corporation doesn't make sense, does it? So that's a really brief talking about the NAT, but we got different types of NAT. One type of NAT is called the source NAT. So what is source NAT? Well, the source NAT is actually what we're talking about, but it's not using the port. For example, this Ubuntu server with an IP of 100.152 tends to go to the internet. So that's fine. But here's the thing. When the packet goes through the router, could be a wireless router or whatever it is, the router says, I've configured a source NAT. And on that source NAT, you've told me if any packets come from 100.2, translate this IP address, for example, to 1.1.1.1. That's called the source NAT. And the router is actually sending your packet with that IP address to the internet. So that's basically how source NAT works. But we got also something else called the destination NAT. Well, destination NAT is a little bit different. Destination NAT is saying there is, for example, a packet coming from the internet, and it want to reaches the port 80 or 443, for example, it's a web server, whatever it is, and the router says is talking to himself, telling hold on a minute, hold on, packet, please stop. I've configured with destination NAT. And on the destination NAT, they've told me if any packets came through the internet on ports 80 or 443, change send them to the IP address of 2.2.2.2. So if any packets from the internet wants to reach these ports in my inside internet or my inside network, it have to go through this IP. So the router would actually kind of redirect the traffic from these ports to this IP, and the Ubuntu server would get it. For example, this IP was actually bind and configured on Ubuntu server. So that's how destination NAT works. We got also something called port forwarding. We were talking about it in the past scenario, that if any private IPv4 address was tending to go to the internet, if NAT was configured, they would use a port, and then they would actually go to the internet. That's port forwarding. We're actually forwarding the traffic using a port. They might have all the same public IP address, but because they're using a specific port, the router would know that how can I actually send the reply back to my clients, because I know which port is for which client. Well, that was all about the NAT. I don't really want to make this video any longer. And the next videos, we're going to talk about how to configure source and destination NAT on Linux operating systems.